So let's have this topic. So for the chi-square test, and take note that the chi-square test is a statistical tools used to check if the two categorical variables are related or independent. So if we have this problem, so if we're going to check if there is a significant relation between the family annual income and the general weighted average of the students, then we have this data. So from this table, observe that there are 24 students. The annual family income is between 210,000 to 240,000. The general weighted average is between 85 to 89. Then there are also 26 students. The annual family income is between 150,000 to 189,000, and the general weighted average is 80 to 84. Then we have these 12 students. The annual family income is below 150,000 and the general weighted average is below 75. So to find if there is a significant relation between these two variables, so we're going to use a chi-square and we're going to solve this problem in an Excel file. So using this Excel file, and this is our observed frequency because the formula for the chi-square, so we have the summation of the quantity of the observed frequency or the FO minus the expected frequency or the FE to the power 2 then all over the expected frequency. So from this observed frequency, so first we need to find the row total and the column total. So to find the row total, so for this row, just highlight everything, then click this auto sum. Then for this row, so highlight, click auto sum. For this row, click auto sum. For this row, click auto sum. And for this row, click auto sum. Then for this column total, so for this column, highlight everything and click auto sum. Highlight and click auto sum. Then for this column, click auto sum. And for this column, click auto sum. Then to find the grand total, so we can use this column total. So just highlight, then click auto sum, or you can use the row total, highlight, then click auto sum. So there are 300 respondents or 300 students. Then on this table, to solve for the expected frequency and formula for the expected frequency, so we have the row total times the column total all over the grand total. So for this cell, to find the expected frequency for these 12 students, so again for this cell using this formula, so we have equals, then open parentheses, then the row total, then times or the asterisk, the column total because we're looking for this cell, then close parentheses, then divide by the grand total, then press enter. So the expected frequency for this 12 is 15. Then for this cell, so equals, then open parentheses, then for this row total, then times the column total because we're looking for this cell, then close parentheses, then divide by the grand total, then press enter. So that's 16.6. Then for this cell, so we have equals, then open parentheses, so this row times this column because we're looking for this cell, then close parentheses, then divide by the grand total equals, then for the cell, so we have equals, open parenthesis, this row, then times this column for this cell, close parenthesis, then divide by the grand total equals, and for this cell, so we have equals, open parenthesis, this row, times this column for this cell, then close parenthesis, divide by the grand total, then press enter. So we have 4.8. So these are the expected frequency for this observed frequency. Then for this remaining frequency, so we're going to copy paste this column, but first we need to lock the row total and the column total. So just click this cell, then we need to put $sign to lock this cell and also the grand total. Put $sign, then press enter. Then for this cell, so again, put $sign for the first and the last, then enter. And for this cell, put $sign for the first and the last. To lock this cell, press enter. Then for this cell, so put $sign for the first and the last, then enter. And the last cell, so we have $sign and the last, entered. In this time you can copy paste now this column. So we have right click, then copy, highlight everything, then press enter. So these are now the expected frequency for this observed frequency. So to check, so just double click. So we have for this cell, so row total times the column total divide by the grand total. So for this cell, so the expected frequency is 20.68. Then for this table, so to find FO minus FE, quantity to the power 2, from this formula, so we have equal sign, open parenthesis, so we have FO, or the observed frequency, so we have this 12 minus the expected frequency for 12 is 15, then close parenthesis, then this symbol to the power 2, because this one is squared, then enter. Then for this table, so you can copy paste everything. So for this cell, so just copy. So we have right click, then copy, then highlight everything, then press enter. So this is now the quantity of FO minus FE, then to the power 2. Then for the last table, so divide by the expected frequency. So these values divide by the expected frequency. So for this cell, so we have equals, then this value divide by the expected frequency. So FE, that's 15. Enter. Then again, for this table, so you can copy paste everything. So right click, copy, then highlight everything, press enter. So this is now the quantity of FO minus FE to the power 2, or over FE. Then to find now the chi-square computed value, since we have this summation symbol, so we need to add everything. So just highlight this cell, then press auto sum, then highlight now this column, press auto sum. So this is the computed chi-square value, that's 18.42. Since the computed chi-square value is 18.42, so we have now the computed chi-square value, that's 18.42. Then this time, we need to find the chi-square critical values, but first, we need to find the degrees of freedom. And formula to solve for the degrees of freedom, So we have DF equals the number of rows minus 1 times the number of columns minus 1. Since our table has 1, 2, 3, 4, 5 number of rows and 1, 2, 3, 4 number of columns, so therefore this becomes 5 minus 1 for the number of rows and 4 minus 1 for the number of columns, and 5 minus 1 is 4 and 4 minus 1, that's 3. So therefore the degrees of freedom is 4 times 3, that's 12. So we have now 12 for the degrees of freedom and 0.05. So we have now the table value, so just connect. So the table value is 21.026. Then these are the things you need to remember for the chi-square test, that if the chi-square computed value is greater than the critical value for the chi-square, then you need to reject the null hypothesis. Then if the chi-square computed value is less than the chi-square critical value, then you need to accept or fail to reject the null hypothesis. So since the computed value is for 18.42 and this 18.42 is less than 21.026, and that's the critical value, so therefore the test is failed to reject the null hypothesis. Since failed to reject the null hypothesis, so therefore there is no significant relation between the family annual income and the general weighted average of the students.